Hello everyone, and welcome back to another GIS statistics tutorial video. And in this video I want to continue our discussion on hypothesis testing and p-values by going in more detail about what a p-value actually means. We're not going to talk about how to calculate one because the calculation sort of varies depending on what test statistic you're talking about, but how do we actually interpret a p-value and what does it mean? All right, so p-value or probability value right, the p-value or the probability value is a number ranging between 0 and 1, right, between 0 and 1. And what this means, what the p-value actually stands for, it is the probability of getting your data or your sample, right, given that the null hypothesis, right, the null hypothesis is true. Right, so to put this in sort of more formal language, this is the probability of getting your sample given the null hypothesis is true. Right. So I know that seems a little weird, and maybe you've heard the p-value discussed in different terms, but what the p-value is actually saying is that what is the probability of having our sample show up? If we were to draw a sample, any sample, right, what is the probability that we would get this sample, assuming that our null hypothesis is true, right? So let's take the question that the t-test answers, right? Again, hypothesis tests are statistical tests that answer a specific question. So let's take the t-test, right? The t-test is basically asking the question, do these two samples have statistically different means, right? And the null hypothesis in this case is that they do not, right? That the means are equal. So in that case, right, the p-value would be the probability that we would get this set of sample data, right, that we would get these two samples, that these two samples have the same mean, right, assuming that they have the same mean. So what you can sort of imagine here is that the higher the p-value, right, the higher the probability value, right, the more likely, right, the more confident you can be that you would get these samples, assuming that the null hypothesis was true. Right, so in the case of the t-test, right, if you got a really high p-value, right, say 0.9 or 0.95, right, you can be fairly confident that you would get these samples if the means were equal. Hopefully that makes sense. Right, so conversely, right, if your p-value is really small, say it was 0.005, right, now you cannot be confident, right? You have very little confidence that you would get these data sets if the means were the same. So you can sort of flip that around and say, okay, well, I don't trust that the means are the same. So I don't feel confident in saying the means are the same. Right. And so let's kind of put that into more formal language, right? When you have a high p-value, right, you use language like we do not reject the null hypothesis, right? When your p-value is high, right, we're saying, well, we don't feel confident saying that these means are statistically different, right? Because our p-value is indicating that it's likely that these two data sets have the same mean. Right? That's what the p-value here is indicating. When you have a low p-value, right, you'll still typically see words like we reject the null hypothesis. Right, and so what this is saying is when the p-value is sufficiently low, we feel confident in saying that we don't think that we would have gotten this data set assuming that they have the same means, right? That's what a low p-value would indicate. Wait, we are rejecting the null hypothesis, right? We're stating that we are assuming that that we would not get this data, right? Given that again, using the t-test as the example, right? When the p-value is low, we're saying we do not feel confident in saying that we got this data given that they have the same means. We're going to go through an example in a later video, so if this isn't making sense right now, that's okay. So again, right, p-value is between 0 and 1, and again, that's the probability of getting your data given that the null hypothesis is true. And when the p-value gets lower and lower and lower, you feel more confident in rejecting the null hypothesis, which would indicate that the alternative hypothesis is more likely. Right. So the last thing that I want to talk about in terms of p-values is what you would typically see, and it's called the alpha threshold, or the alpha value. You see these two terms used somewhat interchangeably. And what the alpha threshold is basically it is the specific p-value, right? It is the specific p-value that we are going to use to sort of create a cutoff between saying that it is high and it is low, right? So this is basically the numeric cutoff. Right, it's the numeric cutoff for rejecting the null hypothesis. Right. So the alpha value or the alpha threshold, right, that is the numeric cutoff. What value are we actually assigning to p, or I shouldn't say assigning, right? What value are we using to determine whether the p-value accepts or rejects or does not reject the null hypothesis, right? And so typically in a lot of cases, in most literature, you're going to see an alpha value of 0.05. And what this means is that when you do everything and you get your p-value, right, if the p-value is less than or equal to 0.05, statistically you would reject the null hypothesis, which means you would move forward assuming that the alternative hypothesis is true. So what does this mean? What does this alpha value mean, right? Obviously it's numeric cutoff, but what does this sort of indicate? Right? This indicates, you can think of this in terms of percentage, right? This would indicate that you have 5% confidence, right? Your p-value is 5%. So you're 5% confident that you would get this data assuming the null hypothesis is true. So if you're less than 5% confident, right, you would be more likely to reject the null hypothesis. Now, before we end the video, I just want to make a quick note on this alpha, right? 0.05 is the sort of commonly used standard, right? But you can sort of imagine cases where maybe you want this to be lower, right? Maybe you're doing a test to say, hey, we have two different groups of people in a medical trial. We gave one a placebo and we gave one actual medicine. And we want to run some tests, get some data, and we want to make sure that the medicine actually had an effect. Right? In that case, right, we're going to use the t-test as an example, right? And let's say we did a test on a drug that is supposed to lower heart rate. And you would give this to patients that have hypertension, right? You want to lower their blood pressure. So we would do something, get some blood pressure results back, and we want to say, does this medicine affect their heart rate, right? Are the means of these populations statistically different? That's what the p-value would be testing, right? And in this case, the null hypothesis would be that they're not, right? The null hypothesis in that case would be that the medicine had no effect, right? So you would get your data, you would run your test, you'd calculate your p-value. But right, we're talking about medicine, and medicine is sort of controversial in some ways, right? And you want to be absolutely certain, beyond a shadow of a doubt, that you can safely reject the null hypothesis, right? That you can safely and confidently say that you're comfortable that your drug actually is different from no drug at all, right? In that case, you might want to use a different alpha value, right? You might want to say 0.005, right? 0.5%, right? You want to have such a low p-value that there is even less of a chance that the null hypothesis, that you would get this data given the null hypothesis, right? So hopefully that makes sense. The point here is that this alpha value, 0.05, is just a suggestion, and there are legitimate cases why you would want to go with a more stringent p-value, and there are legitimate cases why you might want to go with a higher p-value. Hopefully that makes sense. If any of this was confusing, I encourage you to pause the video, go back, rewatch the parts you're confused about, and as always, please reach out. Thank you.